Dear students, in this video we are going so first we will define the photoelectric effect. That word is photoelectric effect. So what is photoelectric effect? How we can define it? So we can define the photoelectric effect as when electromagnetic radiation of sufficiently high frequency. When the electromagnetic radiation of sufficiently high frequency when fall on the metallic surface, like high frequency means like the ultraviolet and X-ray. When these falls on the metallic surface, then as a result electrons are emitted. Electrons are emitted from that metal, and these electrons are called as photoelectrons, and the effect is known as photoelectric effect. So we can say that when electromagnetic radiation of sufficiently high frequency like X-rays and ultraviolet falls on the metallic surface, as a result electrons are emitted. Then these electrons are called as photoelectron, and the effect is known as photoelectric effect. And this photoelectric effect was first discovered by Hertz in 1887, and then experiment was performed by Halloy in 1888. And further, there was another scientist who contributed further and confirmed that the carrier of electricity in the photoelectric effect are photoelectric. So this was the contribution of three scientists, Hertz, Haworth, and Reynolds. So now we go to the experimental setup of photoelectric effect. But before this, here we use the word sufficiently high frequency, so we can produce the photoelectric effect only with the specific light of specific wavelength and frequency. For example, when sodium metal is exposed to the light of wavelength less than 5,455 angstrom, then it will produce the photoelectric effect. And similarly, cesium metal can produce the photoelectric effect when it interacts with the wavelength of 6,438 angstrom. So only the light of specific frequency and wavelength is necessary to observe the photoelectric effect. Now we go to the experimental setup. So how we can perform experiment on the photoelectric effect. So experimental setup is like this one. Here we have an evacuated glass tube. This is glass tube which is highly evacuated. And here we have a window, glass window with the glass tube, and here the light source. And light source is always monochromatic light source. Monochromatic light source mean that the light which contain only a single wavelength. Okay, so such a monochromatic light source is used to fall light on the metallic plates. There are the two metallic plates inside the glass tube, and this one is the tube plate A, and this one is the plate B. So plate B and A and B are such that plate A is the photosensitive plate. This one is the photosensitive plate. That is, when the light fall on this, light shine on this plate, it will emit the electron. So this plate is the photosensitive metallic A plate B, and metallic plate B is that is opposite to the plate A. And here in the circuit we have a microammeter, and in order to read the photoelectric current, and then here is the voltmeter to read the voltage, reading of the voltage, and then these layers are connected in the circuit. Here represents the flow of the current in the circuit, and both these layers are connected with the variable voltage source. So here I can connect it with the variable voltage source. So this is the experimental setup. So when a light fall on this metallic surface from the light source S, then as a result the electrons are emitted. So electrons, these are the electrons, and these electrons are called as photoelectrons. Okay, these electrons start to move towards the plate B when a potential difference is developed with the help of variable voltage source. So when we apply a potential difference between plate A and B such that plate A is at negative potential with respect to plate B, a photoelectron emitted from the plate A are accelerated towards the plate B, and so the result, the photoelectric current flowing in the circuit is measured by this microammeter, and accelerating voltage is measured by this voltmeter V. So when the potential difference is reversed, what happens when we reverse the potential difference? Reverse the potential difference such that now B electrode becomes negative. When we reverse the potential difference, and then A becomes positive. So as a result, when we reverse the potential difference of the battery, then it will reverse the plate on A on B, potential on the A and B. That is, B become negative and A become positive. So when we reverse the potential, now the photoelectrons are which are repelled towards A by the retarding potential difference, and as a consequence, the photocurrent will be reduced in the circuit. So photocurrent is reduced when we reverse the battery voltage. The photocurrent is found to depends on the following on these factors. Now we will discuss the factor on which the photocurrents depend upon. So which factors affect the photoelectric effect? are number one, here the frequency of incident radiation, frequency of incident radiation. Frequency of incident radiation affect the photoelectric effect, and second, the intensity of incident radiation. Intensity of incident radiation. And then thirdly, there is the potential difference between the electrode, potential difference between electrode, and number four, the nature of emitting surface. Nature of emitting surface, that is the plate that emits the electron. So these are the four parameters which affect the photoelectric effect. Now we will discuss that how these parameters will affect the photoelectric effect. Now we will discuss the fact of intensity, fact of intensity of incident light. Okay, how the incident light, intensity of incident light affect the electron or photocurrent. So this is our plot of intensity of incident light, and on y-axis we have photocurrent. And this plot shows us that when accelerating potential difference increased between the electrode, then as a result the photocurrent shown by microammeter reached at its maximum value. That is, with increasing the intensity of incident light, photocurrent increases. So we can say that there is the direct relation between the photocurrent and intensity of incident light. Intensity of incident light. Both are directly proportional to each other. So this experiment was repeated with the different intensity of incident light. So whenever we increase the incident light intensity, that is when we use the light of larger intensity, then photocurrent also increases. That is, photocurrent which is shown by microammeter also show a maximum reading when we increase the intensity of incident light. So this experiment was repeated with the different known intensity of incident light. So the variation of the current with the intensity as shown by this graph, and this graph shows that, this straight line graph shows that the number of photoelectron emitted per second by the surface is directly proportional to the intensity of incident light. So there is the direct relation between these two parameters, that is photocurrent and intensity. Now we go to the next factor,